Is the screen visible?
Yes, ma'am.
Is the screen visible?
Yes, ma'am. Visible.
Okay. So today we'll be again getting into something related to size, speed and the cost. In the last class, quickly I had explained you about the hierarchy of the main memories or hierarchy of the memories itself. So this what this hierarchy tells, why we are studying this. First we have to understand why we are studying this hierarchy. We are studying this because we are studying about the speed, size and cost of the memories. Okay, we are studying this because of these three parameters. So speed, so how the speed is affecting, how the speed is affecting on the performance, how the size is affecting and how the cost is affecting. See, cost is nowhere concerned with the performance. Okay, it is just the matter for the economic purpose, whether they are purchasing or not. So it is not depending upon the performance, but still we are considering that parameter because if it is so because if it is very what you can say affordable, then those things only will be used. But if it is affordable, then we have to compromise with some of the other things also. So that parameter is also considered for the performances. Now all these three parameters will be considered in respect to these hierarchy of the memories. So now which is the fastest memory through which we can access the data very fast? So first in the race comes the registers. So these registers are stored on these registers are present with the processors itself. On the processor chip only we are having the register. So accessing the data from these register is very fast compared to all other memories. But what is the main advantage is it is very fast. Okay, so but what is the main disadvantage of this one here? The size of this, the size of these register is very small. Okay, the size of the registers like 16-bit register, 8-bit register, like this. So because of the storage capacity, we are going for the next level of the memory, that is the cache memory. Yesterday I have explained you that cache memory is of two types, that is level 1 cache and level 2 cache. So what is this cache memory? Cache memory contains the frequently used data, whatever data is being frequently used. For example, you are executing a loop and you are in a loop you are finding out the square of a number. So when you are finding out a square of a number, you are using the instruction x square. So in a loop it may be executed for 10 times. So for the 10 times same instruction is executed. So this is the most frequently used for right now. That is why that instruction is stored in the cache memory. I would like to give a real-time example here. Like for example, see, when you are in a kitchen, so which are the most used ingredients, those will be kept very near to the very in the kitchen. Other things will be kept in the storeroom, is it not? So same thing we are applying here also. So those things like for example sugar, tea powder, coffee powder, rice, these all things we are using every day and frequently we are using them. So we are keeping these things into the kitchen itself. But there are some other things which you are using rarely. For example, you can take the dry fruits. These are not used daily. only sometimes you are going to use it. So what you do, you store it in some storeroom like that. So which are frequently used, that is being stored in this cache. Cache memory is a temporary memory which contains the frequently used data into it. So this cache memory is again divided into level 1 and level 2. What is this level 1? Level 1 means this part of the cache is stored with the processor. It is on the processor chip. So because it can access the data very fast. If it is present near the processor, then the accessing of the data becomes very fast. That is why a part of the cache memory is stored into, yes, anyone want to say something? Rupesh? Okay, so a part of the cache memory is stored with the processor. This is level 1 cache. Then you may think that level 2 cache also can be stored with the processor. Why are we storing outside the processor? The answer is because the processor chip is very small, we cannot put all those memories onto the processor. Because it will increase the size of the chip, plus also the complexity will be increased. That is why only few things will be stored with the processor which are used frequently. So this comes with the registers and the primary cache. Primary cache means the level 1 cache. Next, coming to the secondary cache. These are not different memories. Please make a note that primary cache and secondary cache, these two are not different memories. They are the same memories but divided into different levels. Okay, they are divided into different levels. Now in the second level cache, in the second level cache, what we are doing here is uh, here also some same frequently used data is stored, but it is not present with the processor here. If see, if when you are searching for some data, first that data will be searched in the registers because it is very easily accessible, is it not? So first it is searched in registers. If that data is not present in registers, then next we are going to search in the primary cache, that is level 1 cache. So if the data is present here, then it will be used and the work will be done. Suppose if the data is not present in this primary cache also, then we are going to search for the next level, that is in the secondary cache. So first it is searched in the registers, primary cache, then it is searched in the secondary cache. So secondary cache, primary cache together make the cache memory, but only the venue, or you can say only the place where this cache memory is present are different. So the primary cache is present on the processor and the secondary cache is present outside the processor, but it is present in between the processor and the main memory. Cache memory is a temporary memory. It contains the frequently used data and it is present in between the processor and the main memory. Cache memory is present in between the processor and the main memory. So now suppose if the data is not present in the cache memory, neither in level 1 nor in level 2, then we are going for the main memory. Why we are going for the main memory? Again the issue is regarding the space, or the storage space is very less with this cache memory. So we are going for the main memory. Main memory is having more space for storing the data compared to the registers and the cache memory. Okay, the data which is to be executed, like you want to open a file or you want to execute a C program, you want to hear a song, you want to watch a video, to do anything, to open any application, first that should be brought into the main memory. Unless it is brought into the main memory, we cannot execute it. Okay, so see, when you go, even though you are storing the data in some secondary drives, like for example you are storing in a D drive, data is present in D drive, but by itself it will not on, is it not? By itself that application will not be turned on. First you have to bring that. Bringing means what? Not putting hand into that drive and bringing it to the main memory, nothing like that. Just if you open that particular application, automatically it will be brought to the main memory. If you double click on that, it means it is opening. When that application is being opened, it is present in the main memory. Okay, see, whatever now I am sharing the screen with you. This screen, whatever I am sharing, it is present currently in the main memory. This whatever I am having the name of the file, that is co module 3. Co module 3 is the name of the file. So this file was stored in the D drive. Okay, it was stored in the D drive. It was that time simply resting there. It was not in the main memory, so it was not displaying anything, so it was not opened. But when I double clicked it, automatically that file is being brought into the main memory and it is being visible. So please keep in mind, anything which has to be executed, first it should be brought into the main memory, then only it can be executed. Then till now whatever we have studied, all these are volatile memories. What do you mean by volatile memory? Volatile memory means, yes, anybody, what do you mean by volatile memory? I have explained it many times. Just tell me, what is volatile memory? Anybody? What is volatile memory? You can write your answer in the chat box. Gayatri, can you hear me? Okay, tell me what is volatile memory, Gayatri?
Any power loss or current loss, the data is removed or
Yes.
deleted.
Yeah. The data is lost when there is no power. This is the main, this is the answer for the volatile memories. All these memories are volatile. Registers, cache memory and main memory, all these are volatile. For this purpose, we are next going for the secondary storage devices, that is the magnetic disks. Whatever we are having magnetic disk, we are having the floppy disks, or we are having the magnetic tapes, magnetic drums, like this we are having the secondary memory. These are non-volatile memories. What do you mean by non-volatile? Even if the power cuts off, power is there or power is not there, the data which is stored into it is permanent until you delete it. Until you delete it, the data is permanent into it. So now for example, you are storing some photos in your mobile, is it not? And when you switch off your mobile, all those photos, will they be vanished? Will they be lost or will they be deleted? No. Until and unless you delete them, those photos will not be lost. So that is non-volatileness. Okay. So because of this main disadvantage of being volatile, we are going for the next type of memory, that is non-volatile memory, secondary memory. This is the last in the hierarchy. So this is having more storage, it takes more time for data accessing, and it is non-volatile memory. It is a permanent memory. So these are the memories which are used in hierarchies. So as an when we are going from top to bottom, the size is going on increasing. Register is having something very big size. It is having like 16-bit, 32-bit registers. As we come down to the cache memory, it may become something 512 MB, 1 GB of cache memory. Then when we come down, we may have 2 GB, 4 GB of main memory. Then when we are coming for the secondary, we may be have in terms of 80 GB. This is the simplest one, okay? 80 GB hard disk, this is the simplest one. Now we can have the secondary storage devices up to many GBs we can have. So as you are moving from top to down, the size is increasing, but when you are moving from bottom to top, speed is increasing. Speed with respect to data accessing. So we can access the data very fast in the registers. then a bit slower in the cache memory, then a bit slower in main memory, then it takes more time for accessing the data from the secondary memory. Even the cost is also increasing. As you go on, speed increases, cost also increases. So these are the three parameters which will be considered when you are going to find the performance of a system. Hope all of you have understood this. Next, we are going to study in detail about the cache memories. So just now I had told you what is a cache memory. Cache memory is a temporary memory. It stores the frequently used data. It is present in between the, yeah, tell me. Just tell me, cache memory is present where?
In between the processor and main memory.
Yes, cache, very good. Cache memory is present in between the processor and the main memory. Then it is storing frequently used data. We have already seen it is having level 1 and level 2 cache. But now we are going to see how we are going to use the data which is present in the cache. We are going to use the data in terms of locality of reference. Can you see the cursor here? Cursor, can you see? Arrow mark, can you see the arrow mark? See, I am moving the arrow mark. Can you see it?
Yes,
Okay, so it is telling you about the locality of reference. What do you mean by locality of reference? Means it is the area. It is the area in which you are going to access the data. Now, I told you an example of looping. Okay, so when you are going to do, all of you know what is a loop? What is a loop? What is a loop? Tell me, what is a loop? Loop means executing the same set of statements again and again till some condition is true or false. Okay, so that is called as a loop. So when you are executing a loop, you are using the instructions present in the loop. Means you are using the instruction only of that loop area. Then when you are executing a function, you are using the instruction present only in that area of a function. Then when you are executing the main program, you are using the instruction present in the main program only. So this is called as locality of reference. Locality of reference means these are the areas from which you are using the instructions. Okay, so based on this locality of reference, the cache memory can be set up. That there are two types of locality of references. One is temporal and another is spatial locality of reference. Temporal and spatial locality of reference. What is temporal locality of reference? It means that the recently executed instruction will be used very soon. It is an assumption. Okay, what is locality of reference? It is the area from which you are going to use the instruction. This is with respect to cache memory I am speaking. Okay, with respect to cache memory, what is locality of reference? It means that you are going to use the instruction only of that particular data for some time. After that, you are going to switch to another area. Then you will be using that area for some time. Then you will switch to some another area. So like this, you are going to use the instruction of a particular area for some time. So that is called as locality of reference. There are two types. One is temporal and another is spatial. So what do you mean by spatial? Means it is an assumption that the instruction which is executed right now, it can be used very soon. Okay, it can be used very soon. That is called as a temporary locality of reference. It means that a recently executed instruction is to be likely executed again very soon. Okay, it means that now you have used the instruction number 1. this temporal LOR, LOR means locality of reference, okay. Temporal LOR, it means that the instruction which you have executed might be used again very soon, okay. Such kind of data is present into the cache memory. So when a cache memory is using the temporal LOR, when it is using a temporal LOR, it stores the data with the assumption that the instruction which is just now executed, only that instruction, okay, not other instruction, only that instruction, it might be used again. So such type of data is stored. Now coming to the spatial LOR. What is spatial LOR? It is saying that in the spatial LOR, not only that instruction, but those instructions which are very near to those instruction will also be used. Close proximity. It means that the instruction in the close proximity of the recently executed instruction. Close proximity means very near to the area in which that instruction is present. Those instructions which are present in that area, those instructions also might be used. The first one, what it says only one instruction. Okay, it is referring to only one instruction. But now let me take an example. Suppose what we are doing now, we are having a competition, okay, and you are a group of 4 best friends. Whatever you do, all 4 of you will do together. You are having a group of 4 friends, and now I have organized a competition. If I am thinking like temporal, okay, if I am thinking like temporal, one of your friend takes part. For example, friend number 1. Friend number 1 is participating in that competition, in competition number 1. So I may think that friend number 1 may be participating again in competition number 2, may be participating in again competition number 3 also. Means only I am targeting only that friend. That friend, I am assuming that friend may be used again and again, may be participating in again and again in other competitions also. This is the temporal LOR. Now coming to spatial LOR, I may assume that not only friend 1, friend 2, 3, 4, they are very best friends, is it not? They are very best friends. So all the 4, they are in very near to each other. So those friends also may participate. Spatial means those other friends also may participate. Temporal means only that friend. Understanding now? So temporal LOR means the instruction which is executed, it may be executed again very soon. Such kind of data is present in the cache. Spatial means those instructions which are in close proximity of that executed instruction. Close proximity, very near. Proximity means area, okay. Close proximity means those are close to those instructions. Those will be executed again and again. Such kind of data will be stored. That is the spatial and temporal location of reference or locality of reference. Have you understood this one? Have you understood? Please reply. Have you understood this one? You can reply through the chat box. Okay. So now when a cache memory is using a temporal reference, it means that only one instruction can be brought into the cache memory with the assumption that only that instruction will be executed very soon. But when you are using a spatial, locality of reference, that time that complete block of instructions will be brought. Suppose I am executing instruction number 4. Those other instructions which are near to execute instruction number 4, those other instructions which are near to this instruction number 4, all those also will be brought into the cache memory. So this is how the spatial and temporal will work. Okay, this diagram will tell you how the cache memory is present in between the processor and the main memory, and the data transfer takes place in this manner. Okay, then I will tell you the mechanism how it is working. Now processor requires some data. That data is first searched in the cache memory. Okay, forget about registers and everything. Just remember the cache memory for now. So when the processor is requesting for some data, that data is first searched in the cache memory. If that data is present in the cache memory, well and good, the data will be given to the processor, execution will become very faster. Now for the next, this is called as a cache hit. It is called as a cache hit, H-I-T, cache hit. What do you mean by cache hit? Hit means what? It is successful. Okay, cache hit means the data is found in the cache. Next, coming for when the data is not present in the cache, when the data is not present in the cache, it is called as a cache miss. It is called as a cache miss. What is cache miss? If the data which is required by the processor is not present in the cache memory, then it is called as a cache miss. What will happen when there is a cache miss? When there is a cache miss, the data will be then searched in the main memory. The data will be searched in the main memory. It will be first copied into the cache memory, then it will be given to the processor. So when there is a cache miss, the data will be searched in the main memory. A copy of the data will be first stored in the cache memory, then it will be given to the processor. Tell me why the copy of that data will be stored in the cache memory? Just tell me. Why it will be stored in the cache memory? Because for the next time, if the same data is referenced again, simply no need to go to the main memory. That data can be used from this cache memory itself. So the data is stored into the cache memory. This is the mechanism how it is working, cache memory. Then we are having two operations here, read operation and write operation. So in these two, read and write also, again they are divided into two parts. One is what? Read through and read back. Another is write through and write back. So first let us consider for the write operation. So when we are considering a write operation, this write operation can be done in two ways. This write operation can be done in two ways. The first technique is write through protocol. What do you mean by write through protocol? Is the cache location and the main memory locations are updated simultaneously. Means what? You want to write some data. When you want to write some data, the time the same data is present in two places. It is stored in the cache memory also and it is stored in the main memory also. See, cache memory does not contain any new memory, any new data. Whatever copy is present in the main memory, that copy only will be stored here. It is not containing any new data. It is containing the same copy which is also present into the main memory. So when you want to write something to that, when you want to modify that data, what you have to do? You have to modify in the cache memory also. You have to modify in the main memory also. Why do you want to modify in the both places? If you modify it only one place, then it will be a fake data, inconsistent data. Is it not? If somebody is accessing the data from the main memory, he is going to get some another data. If somebody is going to access from the cache memory, he is going to get some another data. Is it not? If you want to update, you should update to both the places, cache memory also and also the main memory, because the data should be consistent and original updated data. That is what you are doing. Then when you are writing it using the write through protocol, if you are writing if you are using the write through protocol, you are updating the data at the same time on both the places, in the cache memory also and in the main memory also. Okay, you are updating the data. Suppose you want to change the value of variable x value is 10, you want to make it 11. X is equal to 10 is present in the cache memory also, and it is present in the main memory also, but you want to make it 11 now. So when you want to make it 11, you are making 11, you are making it as 11 in the cache memory also and in the main memory also simultaneously. For each time you are updating. Now you want to make the value of x as 9. 9 is modified here also, there also, simultaneously. Simultaneously, when you are doing the modification, that is called as the write through protocol. That is called as the write through protocol. So there is, for each small update, you have to update both the sides. Two update operations are taking place. Two write operations will take place here. Is it not? One you are writing it into the cache memory, another you are writing it into the main memory. So when you are using a write through protocol, two write operations will happen here. Okay, two write operations will happen. What is the advantage here is, you are going to get the updated data all the time here. You are going to get the updated data is the advantage. What is the disadvantage here? The disadvantage here is that for simply changing only one value, you are doing the write operation two times here. So doing the write operation each and every time, so it gives the overhead, it gives the loading, it loads the processor. Simply it is wasting the time in writing again and again for doing only a simple update operation. For that purpose, we are going for the next one, that is the write back protocol. We are going to use the write back protocol. The second method is to update only the cache location and mark it as updated. See, in the second method, this second method is called as a write back protocol. See, it is called as what? See, you can see the arrow mark here. It is called as write back protocol or copy back protocol. What are you doing here is, when you are going to update any data, first you are updating only in the cache block. Okay, when you are going to update that data only in the cache, and one extra bit is associated with every data. That extra bit is called as a modified bit, or it is called as a dirty bit. It is called as a modified bit, or it is called as a dirty bit. So when this bit is set to 1, when the modified bit or the dirty bit, if it is set to 1, it means that that data is being modified. That data is being modified. If that data is not modified, then its value will be 0. If it is modified, the value of that bit will be 1. If the data is not modified, the value of that bit will be 0. Then now you are writing or updating the data only in the cache, but the same data should be also updated into the main memory also. Is it not? So when are you going to update? You are going to update that when you are going to replace that block of data. Cache memory is very small. When you want to execute some new application and that new data is not present into the cache memory and the cache memory is full, what you have to do? You have to do the replacement. Take out some data, old data, and bring in some new data. So when you are doing this writing back, so when you are replacing, when you are going to replace that data, only that time you are going to do the write operation. When you are going to replace the data from the cache block, only at that time you are going to do the write operation depending upon the modified bit. So if the modified bit is set to 1, it means that the data is modified. So you are going to do the write operation again, means you are going to copy that block of data into the main memory. Suppose if the modified bit is set to 0, it is not modified. So when it is not modified, we do not require to copy it into the main memory. Why? Because same copy is present there also. Same copy is present in the main memory and same copy is present in the cache memory also. But when the modified bit is set to 1, it means that that block of data is modified in the cache memory. So when the modified or the updated data is present in the cache memory, that is to be copied into the main memory. So only that time the copy is done. Other time the copy is not done. Just the data will be discarded. just the data will be discarded. It saves one write operation. In this way, the disadvantage of write through protocol can be overcome. So what happens in this write back protocol? Only the cache memory block data is updated, and when it is updated or when it is modified, the modified bit or the dirty bit is set to 1. This is first part. Then when it will be written into the main memory, whenever you are going to replace that particular block of data, whenever a block of data is to be replaced, then its modified bit is checked whether the modified bit is set to 1. If that modified bit is set to 1, then only the copy operation will happen. Then only we are going to write that data into the main memory. Suppose if the modified bit is set to 0, it means that there are no updations. When you don't have any updations to that data, you don't require to copy the same data because already it is present into the main memory. Simply it can be discarded. So this is how it is overcoming the disadvantage of the write through protocol. So this happens with the write operation. Next, coming to the read operation. In the read operation also we are having the read through and read back. Okay, we are having a read through or read back. You can say it is load through. What happens here? So when you are having when you want to read some data from the memory, and if it is a read miss, you can see a read miss or you can say cache miss. Whenever it is a read miss, that time you can read the data in two techniques again. So in the first technique, what you are doing, that is called as a load through. Load through means you are going to search the required data into the main memory, first copy that data into the cache memory, then you are going to give the data to the processor. So you are going to load through. So first you are loading it into cache, then you are loading it into processor. You are going to the load through, or you are doing early restart. It is called also as early reached. It is also called as the early restart. This is the first method. So what happens in the second method? The word may be sent directly to the processor as soon as it is required. So in the second one, what we are doing in the second method, whenever it is required by the processor but it is not present into the cache, then we are going to the main memory, searching that data, taking that data, and directly we are giving it to the processor. We are not storing it into the cache memory first. We are directly giving it into the processor for faster execution. So this is the second method. So this is how read and write operations will be done with the cache memory. All of you have understood this one? Yes, have you understood? So next we are going for the mapping functions. What do you mean by mapping? See, I told you that the data which is present into the main memory, that data should be, a copy of that data is present into the cache memory also. That copy of that data is present into the cache memory also. Now the question is how to identify which block of main memory is present in which block of cache memory. Cache memory is also having its own storage. Main memory is also having its own storage. But we want to know that in the main memory, if it is present at location 3000, then in cache memory where it is present? Yes, Sumit, why have you raised the hand? Do you want to say something? Sumit, do you want to say something? No, ma'am. Then you have raised the hand. Anyways, by mistake it might have happened. Okay. So in which block of the cache memory that particular data is present, we want to know, is it not? For that purpose, we are going for the mapping functions. Mapping functions tell us where, in which block the main memory data is present. So that is done by mapping functions. We are having three types of mapping: direct mapping, associative mapping, set associative mapping. Quickly we'll go through the What is okay? Okay, this will be session will be closed early. Before that, I'll explain you direct mapping. What is direct mapping? Now you can see this is the main memory. Whatever large block we are having now, so this is the main memory and this is the cache memory here. See block number 0, where it is present in cache, block number 127, where it is present in the cache memory, that is to be found out, and that is done by the mapping functions. So we are having what? Uh, Here example they have taken that cache memory is containing 128 blocks. Cache memory is containing 128 blocks, 128 blocks of data. Each block is having 16 words into it. Each block is having 16 words. 16 words into it. One block is one word is equal to 4 bytes. Like that, 16 words are present in one row. Okay, each 128 blocks are there. Each block contains 16 words. This is about cache memory. And the main memory is containing 64k words. Okay, it is, see, main cache memory is containing 2k words. Main memory is containing 64k words. Okay, all of them are 16 words only, each row. Now, in the direct mapping, what they are using a formula there. So, they are using a formula that the jth block of any main memory is present at j modulo 128. J modulo 128 of the cache memory. Modulo means it is finding the remainder. Okay, it is finding the remainder. For example, block number 0 of main memory is present in block number 0 means j is equal to 0 here. J modulo 128. Why I have taken 128? Because there are 128 blocks present in the cache memory here. So 0 mod 128. What is 0 mod 128? It is 0. So block number 0 is present in block number 0 of the cache memory. Next, block number 127. Okay, block number 128. 128 mod 128. What is 128 mod 128? What is remainder? 128 divided by 128. Remainder is 0. So again it is present in the block number 0. Next, block number 256. 256 divided by 128. Remainder is again 0. So block number 0, block number 128, block number 256, all these are present in block number 0 of cache memory. Coming to block number 1. What is 1 mod 128? It is 1. So block number 1 of the main memory is present in block number 1 of the cache memory. Next, 129. 129 divided by 128. What is remainder? 1. So block number 129 of the main memory is present in block number 1 of the cache memory. Next, 257. 257 divided by 128. Remainder is 1 here. So 257 block number of the main memory is present in block number 1 of the cache memory. Understanding this one? So J modulo 128. Why 128? Because there are 128 blocks in the cache memory. So like this mapping is done. So in detail we will be studying tomorrow about this one. So we are going to stop here now. Please don't